Breakout number 2. So in this breakout, we focused on adequacy and gaps. And let's see, here, report out from the main meeting room. All right, come on down.
Hey everyone, so, oh yeah, nice. The first question was, what are the crucial pathways of current observing and modeling to understand these pathways? So the first thing we noted was that actually, even though we have many pathways, most of them can be kind of convoluted ways to go to the processes that we want to, but yet we listed everything we had in mind, which was the Argo program. We've heard a lot about these this week. Ship-based process studies and repeat transect and stations. And we specifically divided those two into two different categories because we thought they were both very important and different. In the repeat transect and stations, we included CFCs and tracers, also biological measurements, TS, etc. Of course, global ocean models, satellite observations, autonomous systems and gliders. Gliders becoming more and more useful. They can carry more and more sensors, including some for biology, even though most of what is noted here is related to the physical world. Then we have moorings, observing arrays for areas of deep water formation. Sorry. Then we just lumped benthic observation in one big box because none of us really knew about this, but we thought it was pretty very important. And and finally, model data synthesis. And because we didn't like to have big slides, we made 3 instead of 1. Let me see. Nice. So that's the number 2 for the second questions. What are the observations missing that we want to add? The first thing that came to mind to everyone is like biology. We don't know enough. Like the physical world has it easier than the biological world. So especially when it comes to fish and midwater organisms, we don't need a lot. A great idea that we heard was whether it was possible to add biological sensors, not just for phytoplankton, to our deep water monitoring floats, for example, acoustics or cameras. Like how awesome would it be to have one acoustic profile of the water column with all the Argo floats every 10 days or so? That would be great. And also optical sediment traps for gravitational flux on the seafloor to have like particle counts and particle size in a very consistent manner, kind of similarly to the Argo program, just sediment traps going up and down every 10 days. That would be cool. Then biology too, because that's also important. The benthos, it is, even though we didn't know a lot about it, we agreed that it was very undersampled and a pretty complex environment, even though it was 2D. And it's important to think about it and to identify the potential anthropogenic impacts that we will have, not considering climate change, but in addition to climate change, so fishing, deep sea mining, etc. Then we have other points that are, they should all have the same size of bullet point. Like this is not a reflection of how important we think they are, but then we are talking about understanding O2, especially at depth, oxygen concentration at depth, spatially and temporally. The coarse resolution of models can be an issue. We've heard about the issue of bathymetry, and we might see improvements in this in the future with Deep Argo. I don't know much about that. Someone was like, maybe it's going to get better. So I was like, yay. So then one point that it's not a specific measurement, but it's just a problem to keep in mind for everything was how can we detect changes below our current detection limits? Like a few people had examples in the room. It's like, well, it's going to change, but if the change is like 1 millimeter per decade and we can only measure up to a centimeter per decade, like we're not going to detect the change, and that might still be an issue. So we need to be aware of that and yeah, take it into consideration. And finally, just a general point that in general, there is great value in doing measurements of physical and biological processes at the same time and place so that we can really have an end-to-end understanding of the local processes. And the last question was, how can new approaches to model help constrain pathways? So the first thing we mentioned was put more data assimilation into models. So check where the models are uncertain so that we can inform observations and get better models, etc. And we would kind of spiral into a virtuous circle where models would help information that would help model that would help information, etc. Then we were talking about uncertainty and whether we should still do something even though we know nothing. And we agreed that it was better to have more complex models with very uncertain rates and still quantify the uncertainty rather than no model at all. And the models can also be great to inspire observations or the other way around, going back to the virtuous cycle. There are feedbacks in both directions. And then we had a long and interesting discussion about machine learning. Some people are like, hey, you know, biology is hard. Let's just do a big machine learning algorithm, put it into a black box and forget about it. And some of us were not totally on board with that idea. And there are issues and concerns with the black box approach. But I think that we were all on board with the principle of trying to use and consider more machine learning tools in our field in general. And yeah, one of the big concerns was, are the principles that the machine learning models were built upon going to hold and stay true in the future under climate change scenario? Like, if you change the rules, the models might not stay true anymore if you don't have the mechanistic understanding behind it. So a potential solution would be to have some kind of middle ground where machine learning tools are used for some very precise parts of the model where we actually have some kind of mechanistic understanding, for example, to constrain some kind of respiration rate or something like that. Then finally, it's important to identify and address model biases. Like we can, some were saying that going at a higher resolution with increased computing powers is naturally gonna solve some issues, for example, by resolving eddies, and yeah, future advances with better numerical modeling will solve a lot of issues. So well, I guess there's hope for the future. That's good. And finally, there just a little summary that we had two ways, and that's going back to the virtuous circle approach again, that we had two ways to approach models. If we have a bunch of models that agree and are very robust, then we can use the observation in those areas to verify the models and yeah, be even more confident in those areas. Whereas if the models do not agree, then maybe we should use observation so that we can like identify the knowledge gap and yeah, see what happens there in more detail. So those were like two different approaches to models and coupling models and observations, and they were both equally valuable. That was us.
All right, classroom number one. Start off with the crucial pieces and missing pieces. So sure, we'd like our wish list to come true, but we've got to think about maintaining and basically keeping what we have long enough that we can make climate inferences from it. So maintenance of our sustained observing system. Talked about the different variables, deep Argo in general. Oxygen kept coming up as one that we highlighted, but one that we weren't sure what the trade-offs would be if you had many, many instruments with just oxygen versus having fewer or higher quality ones with more variables. So an action item. Value in leveraging existing methods, resources, platforms, knowledge, community, basically making sure that we're able to retrieve data, find data that might not be so easily collected or that's been lost in the process of archiving, so that we can basically show the value of that data and increase the value of new data that comes in by being able to make basically a synthesis of what's going on. Okay, to do that, there's human factors that we need to take into account, things like making sure we have national investment, which was also stated as financial investment, which sounds pretty similar. Community building, we have a call out bullet point on it, and it relates to something in the crucial piece above where we wrote down succession plans. So mitigating reliance on single points of failure, thinking of long time, say, scientists who have worked on something in great depth for a long time, but there's not necessarily a way to keep it going forward. And so we thought a way to mitigate that is basically giving credit and encouraging open source projects where there's actually a community of folks that are all working together on it. And so that way it would be more sustainable and more resilient. All right, so the aim is for climate linked records, so things like HOTS and BATS. Maybe, it's a discussion point. Do we need more time series like that? Or is it really we need to make sure that the very long time series don't get broken. So we can do things like understanding the decadal timescales on it. And so that we have at least a few anchors to take field campaigns that happened in different decades and be able to relate them on the same baseline. Okay, we'd like to a little bit more specific here, expanding to seafloor, benthic ecological fluxes and sediment fluxes. Clearly important, both fast and slow time scales. So if you want to, we have very fast sinking, but then we also have fluxes to the sediments being kind of an endpoint, or at least a part that, carbon, nutrients, and so on might be sequestered for longer periods of time. So fast and slow. Identified the southern hemisphere is understudied, and that in the southern hemisphere and in the Arctic, because of rapid changes in the cryosphere, there are so-called, what we've called or coined here, endangered processes. So this is in our diagram that there are links that perhaps have bold arrows today, things like maybe it's Antarctic bottom water formation in multiple sites around Antarctica. That may not continue into the future if there's a lot of, say, freshwater input. Perhaps arrows become thin or dashed arrows or non-existent. Okay, part of the community building was recognizing the FAIR data criterion, be able to pick up orphan data sets, especially it was noted that in biology, some other in fields where there's particular labs that are under a lot of competitive pressure, that maybe the data is not as freely available, and trying to break through that impasse. A lot of data has helicopter parents. You need to call the parent and hope they respond to your email and see if they'll let the kids go out and play. Okay, so more deep biological data plus tools to analyze. We talked a little bit about AI, but I think it's an open question, at least from our group. There's AI image analysis, but how central is that to the pitch we want to make to keep things going? That wasn't clear to me. Okay, and observational data products, open access, synthesized and quality controlled. So it's one thing to have the raw data, but to be able to scientifically interpret it, we need to make sure they're all, basically don't have systematic offsets, that there's not something, basically data artifacts in either the collection or the laboratory that created the data that is clouding our interpretation of the processes going on. All right, anything else from, what group is this? Classroom 1.
Classroom 2.
So for the crucial pieces of both observing and modeling, so first observations, I think that repeats a lot of what's been said already. BGC and Deep Argo time series. And so we talked about the long-term time series and also the big mooring arrays like OSNAP and RAPID, and also the LTER sites. All of those contribute to those long-term observations. Autonomous vehicles beyond Argo that can help us access some areas, especially in winter when it's a little bit more challenging with ships. Satellites, both ocean color, ocean circulation, process studies, and multidisciplinary observations so that we measure both physics, biology, and biogeochemistry at the same time. For models, we identified the CMIP, not CIMP, sorry. All like reanalysis can be really valuable, and also ECHO as a state estimate. And we just in general, in thinking about crucial pieces, we saw the ones that are really needed is that we need both time and space, and we need different locations, both the deep water formations at the high latitudes, but also global for everything that has to do with BGC and mud water formations. And we need both model, sustained observation, and process studies, the three of them, and multidisciplinary, which we said already. And then for the missing pieces and new approaches, for observations, that's part of what we already have, but improving on it would be great to have both time and space resolved, because we still don't fully understand the scales of variability of some of the observations we have. multidisciplinary measurements. It's something that we have in some places, but not always. And so being more careful that when we actually measure something, we have all those different variables. Perhaps identify a bit better the link with society, fisheries, marine life, like all the ways we can advocate for more information. We talked about MCDR also, like how some of those informations are needed to evaluate MCDR, and that can also be a way to leverage getting more observation. And some observations that we don't have enough of, and maybe we want more, would be carbon measurements like PCO2, turbulence measurements, transfer efficiency that we need to better constrain for the biological carbon pump, sediment processes, and some regions like high variability regions and marginal seas that are not necessarily easy to observe, but we should maybe try to prioritize. For models, we talked about how high resolution would improve the models and should be pursued, which has already been mentioned. Data assimilation, same thing. And improving the BGC models, like the ones that go into the big 3D models, basically. And so both improving the parameterization of those models and also the equations. Being able to address physics and address and separate physics and BGC biases, like when you have a coupled model, identify where the biases is coming from, if it's the physics or the biology, and also model ocean and benthos interactions. And then we talked quite a bit also about how to improve like that interface between observation and models, and some aspect that apply to both of them. So the fair data sharing is something else that we talked about quite a bit. So not just sharing the data, but making it findable was a big one. And some of that could be just after is the centralized data store. So we talked about how the Europe as Copernicus, which is like that one place where you can find a lot of things, and maybe something like that in the US could be useful. And just in general, collaborating and sharing of knowledge, because it's not enough to have the data being findable and accessible, but like there's all the knowledge that comes about how to use it that's really needed. And also it would be useful to improve intercomparisons of data with models, and part of it was just using the same units would be something that would help for the modelers. If I missed anything, please go ahead. All right, that's all for us.
Virtual room, go ahead.
Okay. Yeah, so I guess we floated a bit around actually the questions rather than directing them, answering them directly. So this is trying, I guess, to patch with various things that we discussed, like following the questions. But in general, when it comes to crucial observations, I guess, we discussed we didn't really list all of them. We discussed a bit more like alga flows, and again pointed out as throughout the workshop that both the BGC and deep expansion will be crucial to better constrain several important things like ocean heat content, the sea level, biochemical cycles, really in a surface to bottom like sense. But we also spent a bit of time really thinking about the areas where alga flows don't really work well, such as in boundary currents. So we discussed, how you can actually use alga floats in those environments, like parking them, maybe really not in the, especially with deep alga that have more flexibility about where they can be parked at, and so not necessarily in the core of the boundary current, but it will be out of that region very quickly. But again, so that becomes more again the importance of moorings, for example, and discussed also ongoing effort to expand also sensors that could be used when equipping moorings, like oxygen sensors was one that again came up frequently, and in general discuss more also a bit more how can we basically leverage those existing platforms. So what could actually observe as we service moorings, for example, every year. We discussed a bit transit traces again in terms of how they're useful both in ferry ventilation information rates as well as variability in ocean circulation, and in model validations, as well as use them to infer the pathways of other tracers more climatically important, such as anthropogenic carbon. And on that note, I just wanted to add, exciting to see that they're being proposed, to be added for like CMIP7 and so on. But at the same time, from the observational community, there is actually a need to find people to also continue these observations. So it's more of a discussion on actually, again, observations that we kind of give it for granted that will continue in the future. And that's not necessarily the case. I mean, we hope so. But again, we need to find basically new PIs to continue them at a global scale. And then again, there was a big focus on Argo floats, but ship-based observation, of course, are still very crucial in terms of giving a really full high-resolution water column observation, as well as really being one of the main observational sources to constrain carbonate chemistry, as well as other biochemical properties. When it comes to missing observation, we discuss again as mostly like a really lack of observation below 2,000 meters and how that also affects models. And in particular, we focus on I guess that's the core of a deep Argo, but really having at least as a minimum temperature, salinity, and oxygen observations to investigate ocean circulation, classify water masses, look at the deoxygenations, and also my understanding is that at least with these free and neural networks, you can infer also carbon concentrations. And then we discuss more on, well, as was mentioned, biological data is still very limited, and the fact that we really don't have longer term studies to have a proper baseline, like Station M that was presented earlier in the workshop seems to be really quite of an exceptional area. And so without the proper baseline, it's hard, of course, to investigate what the changes will be in the future. And so we discussed a bit how we can improve on that. And from the modeling side, in terms of collaborations, one way is can we use models to actually select the target areas? So, for example, areas that are predicted to experience a stronger deoxygenations or acidifications in the future, could we use, again, models to select areas where we could then set up longer term, basically observational systems. And the other one was as it was mentioned, I guess, before, having cameras also on floats. The problem, again, is a cost. But there's been discussion within the DOOS community about the cheap and deep cameras. I guess the question is how cheap and how deep again. And discussed a bit how can actually add them to Argo floats. And again, the point is not all the sensors added to floats need to be deployed at the global scale. So it could be a much more regional approach. And then we discuss in terms of, again, the lack of mixing observations and how that could be improved. First of all, so again, with the deep Argo, in just increasing the sampling frequency. And how those could be complementary in regional cases with, again, trace release experiments, for example. And when it comes to new modeling, most of these things I think have already been mentioned. It's again, one is using models to improve sampling strategies with OSI, which I never remember the acronym, but I guess observation, simulation experiment. I don't know. I should looked it up. But again, besides, there are ongoing efforts, for example, to use this type of approaches to investigate how many, for example, oxygen sensors should be applied to new Argo floats. But again, it has not been done for other variables. So that's one way to link more observations with models. The other one we discussed about, the need to expand, again, data simulation, for example, state estimates. And the last bit was really we didn't really discuss machine learning, but I guess it's more curious in terms of between new machine learning parameterizations and the use of new models that are based on GPU and so much faster to run. I guess we will have maybe push it to a new definition of what are subgrid processes. So this was just more of a discussion about, it would be interesting to see basically how the pathways, especially at mesoscale, will change in the future. And that's it from us, unless anyone else online wants to add anything.
Awesome. Wow, this is great. And one of the things that I was hearing a lot and that I think we should really appreciate and keep central is the fact that we are all crucial pieces of the observing system. And that and not just all the researchers, but I think we need to pay special attention to the researchers who are open to collaboration, who are thinking interdisciplinarily, who are thinking big picture, and cultivate and invest in them, and just promote that good practice of building an open and kind community, because we're not going to solve these problems otherwise. So carry that in your hearts moving forward. All right, so speaking of moving forward, next up we're going into a breakout for recommendations. But we don't want to just, come up with a big laundry list or come up with, tiny things or too big things that are too big and unachievable. So your task while you're thinking about recommendations is to make sure that your recommendations, you're not only thinking of the recommendation, but also clear actions or concrete steps that you can do to move those forward. And then also identify the timescales of those actions and steps. We're not telling you which time scale is correct. So I don't know if it's going to be a 6-month horizon or a 5-year horizon, but just making sure that we leave with that, because what's the point of all of us getting together to think big thoughts and then let them sit on a shelf again? So that's your task. Now, we like to give you guys things that you can hate on. So here's the priorities that we've been hearing so far. And this is just a starting point. So please agree and disagree and use these for your conversation or throw it out the window for your conversation. But one of the big things that we've been hearing is this need to sustain and expand our global ocean observing system. And so that includes deep Argo with oxygen, maybe other biogeochemical sensors. You guys debate. Increasing time series data, adding key sensors to existing infrastructure, and utilizing long time series like BATS and HOTS. And then, there's been a lot of applications about why do we need to do that? Because we need to expand our understanding of scales of variability in space and time, and to better constrain our models. Because once we better constrain our models, then we can do mechanistic investigations. It's that feedback loop again. We've also heard emphasis on finding hotspots for episodic events to learn more about them, a targeted need to better understand overturning in Antarctica, and then this need to better understand carbon flux once it gets to the deep ocean, going all the way down to the bottom, and what happens at the bottom. So what are the fish doing? Understanding both stocks and fluxes, getting those benthic ecosystem sediment fluxes. So this is kind of your straw man to use to help facilitate your discussion. And let's see, we're going to start up in 10 minutes. Oh, and wait, Heather had something really awesome that she was saying, but Alyssa had downloaded the slide, so I couldn't type it in. Where's she at? Oh, no. Yeah, what was the thing you were saying? No, it was really awesome. And it was at the end, like, we have to make sure that everyone, and then Alyssa took the slides away.
I urge you to transition the thinking from endless wish lists of observations to leveraging what we already have. We're not going to solve the problem of keeping floats in the ocean at this workshop, but we can solve the problem of thinking strategically about the big 5 things that would push this understanding forward. And it requires contributions from all of us. We've been trying to convene the community around the biological carbon pump for 10 years now. And we've chipped away at little pieces of our understanding. And I've been dumping tons of papers into the folder, the resources folder in the workshop participants. And I encourage you to look at that. There's papers in there from Stephanie Henson about how we can maybe start to predict where the episodic the jelly falls, the salt blooms, where these events are, and she's done this global synthesis. I encourage you to take a look at some of these papers. We have papers in there about fish contributions to biological carbon export. So think like process study, like if we're going to do a process study, what would be, you don't have to design it, but think about actionable steps that we can take. We've got the unique thing about this workshop is that we have the physical oceanographers here with the biogeochemists here with the ecologists, and we can really
And the modelers.
and we're all observationalists and modelers. We're all working across that, and so think about how we can kind of button it up and come up with something that's actionable and really focused. I think that's doable, and think about the opportunities, the pathways that already exist for getting that done. What are the funding pathways? What are the, you don't have to just think about federal funding agencies. Think about private foundations like the Schmidt Ocean Institute, which sends the Falcor to part of an ocean basin, you know, every single year. That's an opportunity too. So anyway,
Awesome.
just think actionable.
I love how meta that is. Think about the pathways to address pathways. Awesome. All right.
We had a very open-minded and very candid discussion about different topics, and everybody, very friendly and like, in a very, casual manner discussed their opinions and everything. And we started from, we discussed things from eDNA to, leveraging different techniques that we already have in place and those kind of things. And we kind of have pointed out like 4 or 5 or 6 key areas that we want to more talk about and prioritize them. And you can see a plot, and we kind of ranked them in a doable versus impact space. So first of all, we need to, what we really need to highlight is the importance of the study in a more societal manner. So that everybody kind of understands, like, okay, it's not only for scientific community but for greater general public. It's like very important to study these kind of processes. For that, we need to really understand the stakeholders and highlight the importance to the general public in more rather than the scientific community. People generally understands why it is important. But when you talk these things to the general public, they may not realize why spending $1 million in some floats are important. So we have to really make them understand, like for their daily activity, like forecasting purposes, these floats can be very useful. Another thing that we talked about is that citing the key references of the Argo floats. First of all, like we all agreed that Argo floats are one of the main thing we need to really prioritize. Like a continuous program on the Argo float domain, because that's kind of give us like a real time and like a widespread information or the observations by kind of like low investment or like low effort kind of thing, rather than going to the sea and doing the measurements yourselves. So those kind of thing we definitely have to be prioritized, put forward. And another thing that we noticed that in these days the marine CDR is getting a lot of attention, but and we can leverage some of the marine CDR money to the Argo float development continuation program, because measuring some of those informations are important to really understand the potential of the different MCDR approaches. So that was our number 1 point. And then going to B is we really need to add scalable measurements to the existing observational time series stations that we have, because and that some of the new things that we kind of think is the eDNA, which kind of gives us a more general environmental understanding, and having a long time series of eDNA can kind of give us like the information about the changing biodiversity in that region. So, and it's kind of easy to sample. And although another con of this eDNA is that the science behind the eDNA studies is still evolving. So we really have a place where we can all make our inputs, and maybe we can prioritize what are the kind of tools we wanna develop to study DNA, so that it's like more scalable in a longer term and economical. And machine learning and imaging is one of the very important tools that is becoming more and more commonplace. and using those things, we can do a lot of things which are otherwise is very time consuming and labor intensive. Like, if you have a like an image of in a float, you have a image of the particle, like we saw in the mesopelagic zone, some of these images, and we can program machine learning algorithm that can give us a very good like and a solid information of the community there, and kind of help us understand that. And then going to number C is we also we need to identify hotspot areas to study different pathways. So the hotspot areas means like in the ocean, it's a very vast place. If you like, and there are some key areas where a lot of those things are happening, a lot of different pathways are happening at in one site. So if we deploy our things, in a more sensible way, then we can study a lot of different processes in one place by studying it like rigorously. Some of those plot spots are like deep water formation regions, including the Southern Ocean, the Western Boundary Currents, and then we have to take the key learnings from these time series stations, and then apply them. And yeah, so we can actually like use this information to start new time series stations, but not necessarily as intensive as the existing ones, but take the key learnings from the main longer lasting stations, and employ a subset of those key studies in new stations. That's why we can by investing less money, we can kind of, or less resources, I would say, have useful places for our observational data. Oh, sorry. Yeah. Yeah. Okay. So then, I can skip the D, and D we can skip. The E is like.
You don't have to go as far in depth.
Oh, okay.
Just tell people what's on the slides.
Okay. All right. So, yeah, I mean. Okay. So yeah, I mean, we need to also understand some of the process metabolic rates, which are like kind of not very well known, and then apply it to the different models so that we can have more confidence on what the model is doing. And talking about the model, I think I mean, and we discussed that a lot of our priority has been to lower trophic level in our system models, but it is becoming more and more important that the higher trophic levels are also very important for carbon sequestration and transport export of carbon to from surface to the deep oceans. And so like a CMAP plus FishMAP kind of collaboration can go a long way in coming years, and kind of the model development in that line. And then we came up with a term DEXPORT, like deep export of things, which kind of is a big constraint we need in our model going forward with the climate change, and to understand a lot of things. And then we can basically use to study this kind of deep export, we need to really leverage the existing time series stations, kind of links to the number C. So yeah, and then now we can see that some of the high priority and doable versus importance scale, everything is important. There is nothing low impacting there, but some things are doable, some things are not, which can be seen in this plot. Thank you.
All right, so, oh wow, this is so small on the screen. Okay, that's okay. So classroom 1 talked about many things. We have a very extensive notes document, but this is a highlight. So one thing we talked about is that we need to leverage and expand a lot of the existing observational networks we have. So this is where yes and comes, really into play. We need to, keep funding for Argo, and we need to expand it, auction on deep Argo. And we talked a lot about leveraging, existing platforms. So in the Argo case, leveraging the fact that we have these floats out to maybe play with profile frequency over time or look more at float drifts. So leveraging something that already exists and expanding it. Leveraging GoShip and other repeat hydrography and expanding it to more bio opportunities. Leveraging long-term time series like HOT and BATS, and finding ways to add on deep biology and other observations that we don't currently have there. And then we also talked about, some ways where we might still have some low-hanging fruit, things like, fishing vessels and smart cables and these other platforms that sometimes we don't even think about as scientific platforms. And people are putting scientific observations on these, but there's still room to do more. And we should be thinking about doing more with the things that we already have. Then we talked about new things that we should be doing, and we came up with 2 kind of process studies that would be, we think, especially useful. One of them would be a Southern Ocean overturning study, looking at deep water formation and upwelling in the Southern Ocean. So we had a few ideas about how this would look using, turbulence and tracer measurements to quantify entrainment rates, which we learned from, I think it was Gokhan's talk, or I forget whose talk it was, but I remember entrainment rates are very, very important. And also thinking about where deep water is upwelling right now. And then the other one is kind of, our version of DEXports, thinking about deep export efficiency and targeting episodic events that reach the seafloor. There was a lot of discussion about exactly how to do this, where to do it, when to do it, that would need to get figured out, but we think it's necessary. DEXports. We talked a lot about this question of increasing collaboration across disciplines, and a few things that we brought up is there's ways to think about collaborations across disciplines, just thinking about data access and how we need more things like this, but also ways in which people from different time zones can more easily come together. And so really thinking about how we have big room meetings and ability to talk across disciplines. And one of the things that we talked about was the challenge in getting started off with a new data set that is not interdiscipline. And so if there's ways to kind of find better access to experts within disciplines, forums or something like that to better help people start up ways to collaborate across disciplines. And then we also thought about just like the really big importance when we're talking about yes and of these data sets, it's hard to add something to an existing platform because you really need big picture thinking to add on something because everyone is already maxed out, with the platform that they're already working on. And so, we need to keep thinking about the fact that all of our science is better if more disciplines are included and keep thinking big picture like that. On the topic of integrating observations and models, we had a few thoughts about how, models can help, reanalysis studies or OCs to inform the location and space and time of process studies. We talked a lot about kind of justifying or having a cost benefit analysis of different observations. So, what is the cost of, for example, oxygen on deep Argo and what's the benefit, and models can be used to help kind of compare those things, although there's risks in doing that. And then help use models to inform where and when observations are needed the most. And then we talked a bit about just like other things that we thought were really important to bring up. One of them was the fact that, innovative and, perhaps higher risk proposals are pretty difficult to start up. And there's a really big difference in, a 2-year funding cycle, but it might take way longer than that to start up something new. And so how do we deal with that? We're not really sure, but we want to find ways to encourage people to do new things, even if you might not get something right away out of them, especially among early career PIs. There was, along those lines, we emphasize a lot of promotional thoughts, emphasize number of publications, and we really want to find ways to encourage people to go beyond this. It often leads to a lot of the siloing that we see in disciplines when number of publications is the most important thing. And so if you improve a data set, if you improve an existing data set, that might be more important than publishing a paper. We also want to expand data management sections in proposals. Right now they exist, but they're not always enforced all that well. So we need to not just have them, but expand them. And then we need more funding for quality control and synthesis of data products, and just really getting that out there and helping people use and leverage what we already have. That's classroom one.
We talked about a lot of things, and I'm going to do my best to recall them, but I would call on the group to remember the things I don't remember. Yeah, it's fine. There's a diagram in the folder that I'll start by describing a little bit, but one of the things that we started with remembering is thinking about what pathways we're trying to look at and what we might expect in terms of being able to observe them. So for example, physical processes of all different kinds are bringing climate signals into the deep ocean. And if there's a change in those physical processes, that will also show up in the deep ocean. But for biology, if there's no change in the biological pump magnitude, then we will not expect to see any biogeochemical signatures of that. So the only way we'll see a climate change coming from the biological pump is if there's a change in it. And so it would be very valuable if we could disentangle the biogeochemical signatures in the ocean interior that are due to physics, and then the residual is the biogenic part. And so we started with that kind of framework, talked a bit about that, and then honestly went through some of the questions, but really kind of started talking about things that hit on all of them, I think. And so I'll just go through a very short list of kind of recommendations that is my synthesis, and then my group can speak up for what I missed. And so I think we talked about it would be valuable to understand the magnitude of signals, particularly in the biogeochemistry or in the physics, that we expect to see that would be associated with variability or a change in a physical or biological process, or that pathway. Because if it's a signal we're never going to observe, then that's useful to know too. And also when we see signals, we'll be able to back out what the actual process might have been, even if it is in a bulk sense. One of the things we talked about is that this is a very valuable workshop in terms of the interdisciplinary nature of it and trying to actually understand how each of the different groups kind of thinks about things. And so it would be valuable to continue these types of discussions and to try to see how, just by talking to each other more, we can figure out how to leverage observations we already have. One good example was in the North Atlantic, we have a deep Argo pilot array, we have OSNAP, we have, there was something else up there, lots of observations, but these groups don't always interact and kind of have different goals. But if we kind of could bring them together, that might be a way to leverage existing assets. Kind of one of the ways that we thought about being able to leverage bringing interdisciplinary groups together, excuse me, was developing an interdisciplinary US CLIVAR climate process team as a mechanism to kind of figure out what to prioritize if there were to be a process study, or even just to synthesize existing data sets to learn something about a pathway and how we might expect to observe a change or advance our ability to model that pathway. But CPTs don't have funding for new observations, so it would be a starting point. And one of the other things we talked a lot about was how do we figure out ways to fund things a little bit more fluidly or at a larger scale. And so we talked a little bit about philanthropy and trying to be more aggressive or exploratory in that space. Another one was, can we please get DOE on the hook for all the MCDR impacts? That would be great. They have a lot of money. And there's a lot of downstream effects of localized MCDR applications that should be considered on different timescales. And then the other one was kind of an idea of there's these sort of, I think, NSF rapid grants, but what if there was an interagency kind of opportunistic funding pot of money, so that if there was this process team thinking about places where we might go, and if we knew that there was physical process variability going on, looking to see what the signals look like in both the physical and biogeochemical parameters, or a place where there's a biogeochemical process, something going on that would alter the biogeochemistry or the biology, and then looking for the interior biogeochemical signature, could that help us learn more about those processes? And so essentially a more dynamic interagency funding opportunity that was sort of available for if an event was going on like ENSO or a heat wave or something like that, to jump on it for a process. I think that covers all I kind of remember. Looking at my note taker, anybody want to jump in and add to this? I'm sure there's a lot more, yeah. I think one thing that we also talked about that will be important to keep in mind with all of this is like making sure that there's like clear, like what is the societal relevance, what is the application, and that will hopefully have a bigger impact on like getting more funding, I guess. If someone might be able to say that a little better than me, but it was nice to have a conversation about societal relevance and how can we sell like the deep sea is really important, we should study it, to non-scientists and politicians and other people. So
Can I ask a quick question? And I'm just not that familiar with all the bits and bobs of CLIVAR, but what is a process team different than a working group? And what,
I will pass it to Clivar.
Sorry, I was working on something else. What was the question?
so
Sorry.
think that we get a process team? So what's the difference between a process team or a working group, or is there another thing that's
Right. Sure. So a process team is a funded project. So that's different to do research. That brings together multiple PIs, $1 million plus a year, several across institutions, drawing together those that are building models, at least at 2 U.S. modeling centers. So the model developers, parameterization developers, people that in the community that are working on process understanding, using newly available data set, observational data sets, either from field campaigns or new deployments that are underutilized or haven't been used for this purpose. And so there's an opportunity that will be coming up next year or within the next 2 years by the U.S. CLIVAR agencies, hopefully, that will invite proposals to tackle specific processes in component models or sets of processes, and evaluate those models with those data sets in terms of across the two or more models, how they're performing and where the problems lie, and then help build out new parameterizations. So that's the idea behind the process teams. So it doesn't fund observations. So it's to utilize observations that are available. And these are intended to be shovel ready. So the observational data sets exist. There's interest in the model the modeling centers in tackling this component model. And so that's it. And now we will be in this next round. We still got to work out the details, but we're thinking that we'll inform the proposals by having community white papers that lay out the availability of the observational data sets, the needs. I think, from the discussions this week, it would set up nicely for putting together such a white paper. But that'll be part of a separate process that's really specific to those proposals. I will say those white papers can serve multiple avenues, including CPTs, development of community working groups, which are different. They're limited lifetime, and this is true for OCB as well. Limited lifetime, up to 3 years, about 18 up to 18 members, can be international in its membership, to tackle a set of topics. Again, these aren't funded. We give funding for people to get together for a community workshop, but to support activities like developing metrics and diagnostic approaches, doing review papers, state of the science, setting up MIPS, things like that are attempt to accelerate progress within the community by tackling different aspects. And they're supposed to be fit for purpose ideas. So that's the distinction between the two.
Yeah, and I just that's on. So GoCon had raised this in our discussion group, and I think we sort of revolved around 2 potential ideas based on the discussion, and both of them involved, like a lot of the CPTs today have been very physics oriented, and so the idea was sort of, how do we extend those to include sort of the biogeochemistry and so forth. And the two that I think came up most were, at the deep water formation, sort of the physical and biogeochemical impacts and dynamics, the idea that there were unique signatures in the biogeochemistry that could really help us to understand the strengths and weaknesses of the physics. And then the other one that we discussed quite a bit was, kind of building off of Mara Freilich's talk and others about, so there's been a lot of work on sub-mesoscale and mesoscale processes in the physics that could naturally be extended to the biogeochemistry to understand, not just the physical effects of those finer scale processes, but the biogeochemical imprints that they leave and how we parameterize them better. So those were kind of two examples that were discussed in the session, but by no means would they limit the number that we could discuss.
All right, and sorry to kind of derail us because we still have the virtual room to go, but maybe we'll continue the discussion about next steps. Thank you for bringing up that process team. I had no idea that was a thing. That's awesome. Let's go and take it into the virtual space.
Okay, so in the breakout room, we first discussed about priorities for observations and models. And so we identified essential ocean variables, which include variables like temperature, salinity, and oxygen as a key observational priority. And we also recommended that biological observations should leverage existing observing programs, such as Station M off the coast of Monterey Bay, and also to be able to then draw connections with the physical state using the information from the essential ocean variables. And with respect to the modeling side, we've identified that, like, in addition to global models, regional models will also be helpful in terms of identifying and understanding driving processes, given that for some global models, they may not have a sufficient resolution to be able to represent like all processes, particularly small scale ones. And carrying on that conversation into specifying which processes to focus on, we identified at least two processes. The first one is deep western boundary currents because of variability in the EOVs, as well as the flow along the boundary currents being stronger than the interior, which could have potential implications for number one, suspension feeders, and also number two, the for example, the dispersal of organisms such as larvae and plankton. And we also identified mythopelagic layers as another process study to focus on, given the uncertainties associated with the vertical migration pond. So we then discussed about how we can increase collaborations across disciplines. So the first point that came up was to facilitate data access to, such as Argo flows, and specifically to increase data documentation and data product availability so that it's more accessible towards scientists of different disciplines. We also focused more on the early career activities as well, i.e. how we can train early career scientists to be able to collaborate more extensively with scientists of different disciplines. And so some of these possible examples include workshops to learn about datasets and model abilities, but also summer schools to, for example, train biologists in physics and vice versa. But one of the other important points that came up is open communication and increased exchange between modelers and observationalists as a key to address scientific questions despite imperfections in comparing observations and models. And to do that, we thought that like having number one, an importance of open exchange, and also number two, in a more practical sense, having a development of a united dictionary among disciplines to avoid confusions between terminologies from different disciplines in oceanography. Lastly, we discussed about how we can better integrate observations and models. And so we've pointed out that one, lack of understanding from observationalists about appropriate models to use for comparing model outputs to observations, but also lack of understanding from modelers about some of the key biological processes that drive changes in ocean signals, such as fluctuations in oxygen and nutrients. And so one solution that we have proposed is to promote interdisciplinary research. And so that could, for example, include opportunities for fieldwork with the Schmidt Ocean Institute or Rev Ocean, as well as interdisciplinary calls for funding agencies. So that concludes my summary of the virtual breakout.
All right, thank you very much. All right, so for the next 25 minutes, we're at the conclusions and future steps. Monique and Shenfeng, I don't know if you guys had any specific ideas around this. I figured it could be a good, just do some group brainstorming. And yeah. And one thing I was thinking about, we only have 25 minutes, right? So we're not going to fully flesh out deck sports. But I think what we can work on fleshing out is the communication pathways toward how we are going to be, moving these things forward. And I think in terms of, do we want to go for being a working group? Do we want to stay in touch? Who wants to stay in touch? And kind of what we want to build from here. And then once we build something, then you get the group of people together to write the Argo white paper. Then you get the group of people together to start doing the exports. I don't know. What do you guys think? Does that sound like a good place to start? And I would also like to ask for a lovely volunteer to do the writing on the whiteboard for me, so I don't have to write. Any volunteers? Come on, guys. My shoulder was reconstructed 6 months ago. Okay, good. Yay. All because of that. Awesome. Sweet. Do you want to do it over there or over here?
I think, is this more visible? Because it's not.
Yeah, because I'll be in the way here.
Did you scan a picture of this?
Yes. Yeah, we got a picture. Thank you. Hannah gets a gold star on her lunchbox then. Yes. Anyone want to kick us off with anything you've been thinking about for the future next steps?
I think we're gonna work on maybe come up with a review paper to review our current understanding about some pathways we discussed during the workshop, and also the gaps in understanding those pathways, and make some suggestions. I guess we have a lot of material here already during the workshop. Yeah.
And I'm wondering, it kind of became clear as we've been talking about how do we get the Argo that we all need, right? That a review paper may work for that by really highlighting all of the scientific applications and societal impact of that. How many review papers do we want to write? I'm wondering if a review paper on the current status of knowledge and gaps is the way to go, or a more poignant review paper is the way to go. Yeah, good. I got some hands up.
Nuts in it. I'm allergic to peanuts, so please don't eat the peanut ones if you can avoid it. They're the good bars, I think.
Okay. No peanut candy. Let me take a look at the package.
It's just the good bar. It's just the yellow ones.
Yeah, the yellow one.
Sorry. Thank you.
No, thank you.
Yes.
Okay, great.
Yeah, I wonder if maybe one review paper and then something more like a perspectives type paper that could be like Lisa Levin had that one paper that was like a 1.5 pager or something. So maybe something like that. In addition to a more comprehensive review paper.
No, that's great. That's a great idea. Lynn, do you have something to say?
Nice.
Having something that is really high profile as a summary of a review paper of needs could be helpful.
Sweet. Yeah.
Like you said, yeah, and have that short one be high profile.
Right. Any other thoughts on, and we'll have a workshop report that we're putting together. And so the co-chairs will be hearing about that, or the SOC will be hearing about that too. Yeah.
Also with the review papers, we might want to, or even the workshop report, we might want to think critically about program managers that we might want to make sure get a copy of that.
Yeah. No, that's a good point. Yeah, Charles.
Give myself to Mike. So I haven't done a lot of deep ocean work, but one of the things I was wrestling with throughout the meeting was what is the most compelling why? You know, why do we want to spend $100 million on this? And I think, you know, Lisa gave a lot of, you know, interesting reasons why society should care about the deep ocean and so forth. And they and you could make an argument for every one of those, but in difficult budgetary times, I was wondering what's the one that really is gonna make the compelling case, and where my mind kept going was this, you know, there's this big emphasis on marine CDR and this compelling societal need to understand how we address this carbon issue. And the deep ocean is our largest natural marine carbon dioxide removal mechanism, right? And there are papers and studies that suggest that relatively modest changes in any of the dynamics that we're talking about here, whether it's the deep water formation, the remineralization length scale, and other things, can have a profound effect on the amount of carbon dioxide that remains in the atmosphere. And I guess I'm kind of wondering, as we talk about these reviews, papers, and other things, you know, is that the case? You know, is that the case we really want to stand on most? And is that the case that's going to enable us, you know, like this community to go in and argue on equal footing with the satellite observing community that, you know, we need to take a part of that money and put it in the deep ocean because that's where the carbon is. And you know, and I love deep sea ecosystems. Fascinating, amazing. But I don't know if that's going to win the day. But maybe the carbon problem will. So
just picking up on that, I think there's maybe two concepts buried in your comment, which is one is the MCDR angle. The other one is just climate driven disruptions to the natural carbon sequestration process. And so like, I think that can couple to tipping elements that already are kind of in the public consciousness and getting a lot of funding, like, you know, OSNAP is to monitor the potential collapse of the overturning circulation. And I think the connection between those processes and biogeochemistry, I don't think that's a big part of OSNAP, for example, but maybe making those links clearer can help that the biogeochemistry also get kind of into the public consciousness of like, you know, there should be like a movie like The Day After Tomorrow, which is like what happens when the biological pump like collapses because of the overturning. I don't know, something like that.
Starts with scientists being like, all the zooplankton are dying.
And I think it's also helpful to connect changes in heat and carbon and oxygen and a lot of these things we're talking about to fisheries. We haven't talked a ton about that. But, you know, when there's marine heat waves in the Gulf of Maine, that has huge impacts on the lobster catch, stuff like that, I think is also compelling. I know at NOAA we often like link it back to fisheries, and that seems to be a helpful way to get funding.
Yeah, for sure. There was a heat wave off of Chile, Peru, and it hurt the salmon aquaculture industry $800 million. So
Yeah, actually, in my in our breakout room, we also briefly discussed that. One kind of part about that is usually the fishery. I think Charles mentioned that is confined to maybe 500 meter, couple 500 meter.
but I don't think that's the problem that wins the day for Argo, right? Because if you look at a map of Argo, it stops before the shelf. And so I think fisheries recognizes the importance of Argo, recognizes there's information flowing in, tuna, traverse the deep seas and so forth. But the crux of the fisheries challenge is on the shelf. So I think that could be part of the rationale, but should it be the biggest part? Because I think what you find is, well, we should really do gliders instead of Argo because that's where the fish are. And so I think it should be an extra benefit, but maybe not the core benefit. And it's hard for me to say because that's what I do most of my time.
Does anyone have the number on hand, the size of the carbon reservoir in the ocean versus the rest of the world? It's like some stupid awesome number.
It's taken up a third,
Yeah.
roughly, of the carbon, right? And so it's the.
45 times part of the atmosphere.
4 to 5 times more than the atmosphere.
And I think there's a nice paper by Lin Kwan from 2009 that makes the argument that even a subtle change in that remineralization length scale can lead to, say, 20 parts per million difference in the CO2 that's in the atmosphere. That's a bigger change than any artificial marine CDR technique that we're talking about, right? That's, if you're pumping alkalinity into San Francisco Bay, you're not going to get that. And so, I don't know, naively, that's where I would think the first place to hang the hat would be, the ocean's the world's most natural carbon dioxide removal mechanism, and we don't understand that. And I do think that the BGC Argo and the models and a lot of the things we're talking about during this meeting would be the core of that. That would be the Mauna Loa and the global temperature network that allowed us to understand climate change. And this just takes it to depth. And then you argue for it with the satellites, because that's where the money is, right?
So just putting some numbers on the carbon cycle here. The figure I have from the Friedlingstein paper, 2022, this DIC, 37,000 gigatons of carbon, atmosphere 875. And then we have 1,700 for soils and 1,750 for surface sediments in the ocean, which do we really know that?
Yeah, so just quickly extending Charles's point is that I think, yes, and yeah, so the Charlie? Okay, Charlie. So because the satellites, like, if I'm not mistaken, there are satellites that are trying to constrain the terrestrial carbon stock, and that is, probably easier to do with just satellites than getting the ocean carbon export. And so maybe there's an argument to be made there that, like, really you need deep Argo to do the equivalent thing that you can do on land in other programs, and that might help put the funding on a comparable level to another process.
And to extend even further what Charlie said, if the focus is carbon sequestration, so tons of carbon sequester, as Tim told us, this is the product of the export, which is all biological, and the residence time, which is more of a physical quantity. So we can really bring the circulation and ventilation and the biology together with that quantity. So it's a kind of a nice framework that encompasses everything that we have discussed so far. So I like that point of view.
Yeah, I was just going to make the point that the land carbon stuff is really pretty uncertain. There was a big advance not that long ago where they can independently estimate certain things, which helped with the budgeting. But I'm always a little bit wary of comparing the ocean to the land sink because people will be like, oh, wow, you guys really have that figured out compared to them. So just a caution.
We got Alyssa over there for online.
Yeah, there is a comment from Lisa Levin. Lisa, do you want to unmute and voice that?
Just a comment that deoxygenation comes into almost everything that's been said. But certainly it's one of the ways that climate change is disrupting can be disrupting the natural carbon cycle.
Yeah, it's a good one.
Oh, I want to, I think another point is a heat, like the basic temperature change. We know that the ocean is the largest heat reservoir in the climate system. And we know a lot about the upper ocean heat content change, but deep ocean, we know something based on the just repeated hydrographic measurement, ghost shaped wells. But still, how much heat the deep ocean can further take, and whether those heat are going to come up or something. Those kind of similar to the carbon cycle idea, like, but we don't fully know that, and that's a big thing. That's also related to this.
Yeah, and related to that would be sea level also, and that obviously has, in terms of compelling whys, I think sea level rise is a very compelling why for us to include in this discussion.
Oh yeah, I didn't want to derail now going backwards because I think that's related and valuable topic, but I just wanted to related to the MCDR, just to point out for those of you who maybe haven't engaged in that conversation as much, the flip side of MCDR is MRV, monitoring, reporting, and verification, and so that whole industry of MCDR requires MRV, which is the actually measuring the carbon export and sequestration. And so these types of tools are observing and modeling. It requires both observing and modeling. So for that industry to be successful, it would require actually being able to do all of the things that we have talked about that we want to do for our scientific purposes. So that's another way to frame it. Whether you feel good about that or not, I mean, is another question. And then I feel like I had a similar thought to that. Oh yeah, so anyway, it's not just for providing the baseline, but also like those industries actually need these capabilities to be successful. So I just want to point that out.
Yeah, I just had a very quick point about the why that we haven't mentioned yet. It's the models. Like, I don't know to what extent deep Argo is assimilated in models, but we talked in our breaking group about that a little bit, like whether that can improve the models and that have social relevance because of that reason too.
What's the word? What is it? Metals? Oh, models. Not models. Yeah, like data assimilation. Like Helen.
You know, how much are the data being assimilated in models? How much change there is in the models when they assimilate it? It does, yeah. But there's state estimates and data assimilation. Other people can talk about this more. That use Argo and that and biogeochemical adjoints have been developed and are being used and are ready to go global. So, and are global. Yeah.
And then we'll go.
For BDC Argo, I think there's a lot of studies from Matt Maslov and people to show the observation impact. But from the deep Argo pilot arrays, that work is still underway. So I don't think that's been published yet. But there are OSCEs where they've assimilated synthetic data that represents what the acquisitions would be from, for example, a global fleet of deep Argo. I think that was Gasparin. And they've showed that it is really valuable for removing or ameliorating some of the deep temperature biases. Yeah.
Yeah, go ahead, Mitchell.
Yeah, so it was Gasparin. I've read that paper as well. But to derail that conversation again and go back to the carbon one that we're talking about, maybe this is like knowledge here, but where is a lot of the MCDR and MRV like funding coming from? And is there any way that like we as a scientific community can tap into that rather than like the startups and like et cetera that are getting a lot of that money?
So folks, correct me if you know more about this than I do, but so there was an X Prize for MCDR development. And so a bunch of people are competing for that X Prize to then take their technology and scale it up. So there's that money. And then a lot of the MRV companies are getting funding by pre-selling carbon credits. And so, yeah.
So not really then.
Yeah.
Yeah, there's also DOE, the ARPA-E program was a big one recently. And then I thought there's NOAA funding as well. Yeah. Oh, okay.
Academia and some other sector.
And that was the same for ARPA-E.
Says API. That's not, yeah. So we got one with collaboration with NOAA as a government. I mean, FDL as a government.
So I just want to circle us back again. 5 minutes left. I think these are all really great whys. I think we've got a really good list of things we can do. And so going back to Charlie's original metaphor. By the way, did you know my son's first name is Charles? He just goes by his middle name. All right. So, okay, we have a hat and we're trying to figure out what to hang our hat on. Is it MRV? Is it sea level rise? What's the most important thing? My question to you guys is, what is this hat? What does the hat look like? How do we move forward together to get stuff done? What would you guys like to see with that? Because, yeah, go ahead, Zach.
Yeah, I was just going to say, I think there's kind of 3 different things we want to do, like 3 big buckets. Bucket 1 is making sure that programs that already exist get continued. And I think this is a great thing for the review paper to say, or either a report or something to say, this is going on and needs to keep going on. And we could name the programs, but we probably already know what they are. Number 2 is expanding things that already exist. So we do this and we could expand it a little bit to do this. And I think the report could do a really excellent job at saying, here are a few things. So oxygen on deep Argo is one of them, for example, that we should really encourage leveraging existing platforms to do. The eDNA and GoShip is another one. Yeah, the perspectives paper could do that. The third thing I think is the new stuff. This is the process studies, and we've had a few examples. And this is what, yep, that's one of them. There's a few, like maybe 5 or so that have been kind of ideas that are out there. And that's the one I'm kind of struggling with. And I'm wondering if the right thing to do is to kind of put examples of these in the workshop report. And then I don't know what the next step is, but I think the next step for that might look more like a climate process team from CLIVAR, or because you really need 1 or 2 people to really move each of those things forward. And I think that's going to be the hard thing to figure out what the next step there is, to identify who's going to keep going and who's going to make the next thing happen, because we probably can't push forward in all 5 of them.
Aren't most of the process studies that we talked about would require substantial new observations? So I think those don't actually fit well with the climate process team. So maybe part of what we should do is to identify what do we actually know enough about in terms of observations that is shovel ready to develop new, implement in models, and then separately what requires new field campaigns. And I don't know what the funding is for that, but probably like NSF or I don't know.
Yes. So I'm gonna put on my federal hat here and channel the discussions I get pulled into, and that. And yeah, so you said what we want to do is continue programs that exist, expand the ones. If I'm a federal program, I would say, well, why? It's sort of we want to do it, but the why, so. I mean, I say this to satellite folks all the time. It's like, why do we need another satellite? Why do we? And so I think that's our challenge, right? Is not to say we want to continue these programs that exist, expand them, and have these process studies. It's all going to go back to, if we do this, this is what we'll understand, and this is how it'll be critical for society. So I agree with it in principle, that in my heart of hearts, I think that that's the case, right? But the challenge for this paper is to really convey in a compelling way why.
So I guess my prompt was, tell me what the hat looks like, and then we hang the hat over there. So don't worry.
it's hard to talk about what the hat should look like unless you know why.
That's a really good point. Yeah, yeah. And we have Andrea over there.
Yeah, I guess 2 points. One is, I think Lisa said this, and if she didn't, I know she probably thinks it when she was talking about the oxygen, is the biodiversity loss. And even if fish live primarily coastally, or those are the ones we care about for economic reasons, like ocean ecosystems don't have fixed boundaries. So if you start modifying the habitat of certain things, it can have trickle down effects. So I really do think that like habitat changes, biodiversity loss, and unknown consequences to things we do care about that we might fish coastally is important. I think that that could be sold. The public does respond to, loss, species diversity loss, essentially. So I think that could be part of the argument, but maybe it's multiple things. And then I do think it's important to improve process representation in models, but I also think that we should be really careful about how we do that, because if it's something that doesn't leave a large enough chemical or physical signal to ever observe, we will never be able to validate it. So I think it's kind of important to think about trying to improve our understanding of processes that we might have a chance at actually observing, so that when we do observe them, we can validate the process in the model. But I would love to hear a modeler's perspective on that.
I was just thinking about our hat and hanger thing again. You got to know what the hanger looks like to design the hat that's going to fit on it.
I don't know if this is like a good idea or not, but I just keep thinking about one of the suggestions from the virtual group was a summer school, and just thinking about how do you continue like these interdisciplinary collaborations, and even honing in on how would you design a process study? Like, what are the important things, and how do you facilitate that type of yeah, it was funny. It's driving me crazy. How do you facilitate those interactions? And, something like a summer school is a way to like bring interdisciplinary scientists together. They have to work together to teach some kind of coherent interdisciplinary topic. And then you have the students who are being trained to think in that way too. So I don't know, that sounds like a lot of work, and I don't know how you would do that, but it's just like, I thought that was a really good idea.
I'm getting multiple signals. We're running out of time, and Alyssa has something.
US CLIVAR, we are currently accepting proposals for meetings, including summer schools.
Oh yeah, I was just about to ask, where do we get funding for that?
Yeah, and what I was working on earlier was our working group that's putting together summer school. They're doing the selection today, and I will say it really benefits from having a working group. So there's a lot of activities here that are on this left-hand side that might benefit by having you continue the dialogue from this meeting with a smaller group of people that map out opportunities like summer schools, like future community meetings on the topic, that can really drill in on this issue of how well assessment of our model capabilities, what processes need to be improved, what as motivation for process studies and helping to prioritize, and then feeding that back and involving the community in the development of those ideas, and then setting the next stage for those observational campaigns that will link back to, we've been talking at breakfast, I've had 2 different conversations about the importance of having, as a best practice, having the modeling groups involved at the front end of planning for process studies. And in doing so, when the observations then become available, you'll have a ready audience at the modeling centers, but also within the broader modeling community to uptake those observations and evaluate the model performance, but also improving the pathway for improvement of models, and make a pitch for a climate process team downstream. So working groups are a good way to keep the conversation going and moving forward activities in this space.
All right, so this isn't do you want to be in the working group? Who thinks generating a working group surrounding this topic would be beneficial? Raise your hand. Gauge impact. Who is vehemently opposed to seeing a working group developed on said topic? Or slightly opposed, or just doesn't care? Okay, great. Anyone online who doesn't like the idea? Yeah.
In terms of time frame, so each fall, US CLIVAR will put out a call, typically in September. For this topic, we'd be coordinating with OCB and Heather.
Oh man.
What's your timetable? I think we've done this before where we've had joint working groups. What's your timetable for working group call?
We do one annual call, which we release usually in mid-August, and proposals for anything, a working group, a workshop, a training activity, they are due usually in mid-October. And we
Yeah, so
make
that corresponds with ours. So I think, if the focus on the next steps on getting reports or articles and workshop report that we can get in front of the agencies for their consideration, it'll set the stage well to pitch, even in this next round, a new working group.
Sweet. All right, guys, we are 6 minutes over. I know many of you are going straight to the airport. Does anyone have any last burning things that they want to say? Okay, let's all give Hannah a very big round of applause for writing this all down. There it is. There it is. And I want to just thank you guys for buying in, being open and kind, focusing on the yes and. I think this was really productive. And I'm really excited to see what we make of it.
Oh, yeah, thank you for being here, for the very productive. I think everybody learned a lot. I personally learned a lot from a lot of colleagues here. Yeah, let's keep this conversation going and get some great things done. Okay.
Can I have real quick just one final thank you to the SOC who planned this, put a lot of hard work into it, a lot of their time to make this such a great experience for y'all. So a round of applause for the SOC.
Actually, Denise.
Well, we definitely need a round of applause for the organizing committee that helped so much for all of the meetings and preparing the workshop and everything. So thank you to you guys.
And a final one, thank you so much to Xinfeng for hosting us in your hometown.